All right, perfect. So recording has started. Let me just start the slideshow. Okay, and also the tab. All right, so last thing we discussed, we answered some of the questions that you brought, and we saw that only one question left, which is the prime, right? If we go back to our questions, the last one, return the power of this has been solved. Okay. Okay, so the only question that we didn't answer is this one. Returns true if a given number is a prime number, and we explained the idea of prime numbers. We said the prime number is the number that accepts division only on one and itself. So I'll give you 5 minutes or 4 minutes to think about an answer for this, how to write the code. Okay, and then I'll ask you how to do it, I will answer it for sure for you. But I want to think first of an answer. Okay, so any answer? Anybody found any answer? Nothing? All right then. I'll leave it as an assignment to you today, okay? And I will answer it next lecture, because I want you to do things yourself. So I'll continue with where we stopped last time, which is the default arguments in functions. The default arguments, sometimes you can assign a value to the argument. So if you don't pass this argument, it will take the default value. And this can be done like this. For example, here I defined integer, a function, square of integer x. If it's just like this only, that means you have to pass an argument to this function. For example, here return x times x, which is square. So if I want to use it in the main function, I have to pass an argument. For example, cout square of 4, okay, or cout square of 2, or any number. But in some cases, you don't need to pass, or sometimes you don't pass an argument. So in this case, it takes the default value. In this case, you don't need to pass an argument. If you can see this, integer x equal 5, integer y equals square of x. So here I passed 5, right? This 5 will go here, will discard or override the value 2 and put 5 instead. Then return 5 times 5, which is 25, and return it to the function. But in the second case, I didn't pass any argument here. So nothing will go to the function. The function will see that the main function didn't pass any argument, so it will take the default value, which is 2 in this case. I'll show you how, of course, the execution is here, 25 and 4. I'll show you this practically. Okay. Also, there's another example I will share it with you. So here, okay. Good. I will just increase the size. With IO stream using namespace std, and here I'll define the function integer sq of integer x, right? Here return x times x. Intentionally, I didn't put the default value yet. And here in the main function, integer main, cout sq, capital SQ, of 4, for example, NDL, and that's it, return 0. And that's it. Okay, if I execute this, then I'll pass 4 here to the function. It will return 16, and the answer will be printed at the end. Error, we have error here. Let me, we have extra character. All right, so 16. I got the result, which is 16. Now, if I don't pass any argument here, I leave it blank, I'll get an error. Let's see the error that we will get. See, the first error is here. Too few argument to function integer SQ. Too few argument means the number of arguments that I have passed is less than the required number of arguments in the function. And here another error. Declare, not declare here, as declared here. So if I modify this a little bit, I give it, for example, equal 2. So if I don't pass an argument from here, it will take the default value. Let's try it. Okay, so if you can see here, I got an answer here, 4, while I didn't pass any argument here. So this is called the default value. In this case, if you don't pass an argument, then just let me explain it here. In this case, I didn't pass any argument here. Okay, so what happened here is, since I didn't pass any argument to the function thought that I want to use the default value, so it assigned 2 to x and executed the multiplication and returned the value. Is declared this default value. I have another example also, I'll share it with you. This is the second example. I just wrote it. Okay, so here the example is a function. I'll write it here. Write a function that receives your name and the country. Not, I'm sorry, I'm using Python notation. Okay, and the country that you are living in, and print it. Okay, print the information. This information. If you did not send, okay, the country, then the default is Oman. All right. So see, in this case, I will just send information to the function print info. Okay, string name. It takes string name and string country. Here I added equals Oman by default. If I don't pass the argument to this part or this parameter to the function, then it will take the default, which is Oman. So I'll try this one. I defined string n equal Muhammad, string c equal Iraq, print n and c. Okay, so if I execute this, I'll get the message, this message. Your name is, and you live in the country that I passed. Now, what if I don't pass the country? If I remove the second, then it will take the default. All right, let's run it and see. It took the default here. All right. What if I don't want to pass, or I want to set a default for the name as well? So name equals XYZ. All right, it should be as a string XYZ. So see, now I passed only the first argument, right? It takes the first argument, but the second argument is the default value. So in this case, if I run it, I'll get the same result here. But if I don't pass the first argument also, if I only call the function, it will take the two default arguments. Okay? See, the function here found that no argument have been passed, arguments have been passed to this function. So it considers the default in both cases. Okay? So this is the definition of the default values in the function. Also, I'll print this to you. But here I'll remove the first one, this modification. Okay. I'll add as another slide here. Okay, this is an example of the default function. Let's see what else we have. What's left? Okay, now overloading. See, actually, an overloading is very important in the functions. That, if you remember, when we talked about, let me just increase the size. Or okay, here I can define the same function with different types. For example, here square will be square. All right, the same function, the same functionality, but the type is different. I don't need to define different kind of functions. I'll define functions, the same functions, but I'll change the types here. So when I call the function, the program will ask or will check the type of the input and execute the function, the required function according to this. I will give you an example better. Okay, so here if I define two functions. The first function is integer square of integer x, and here return x times x. Okay, and I define another one, double square of double x, and here also return x times x. If you can see, the functions are identical, but the difference here is what? The difference is the type. Here integer, and here double and double. So if in the main function, if I define, for example, double x equal 1.2 and write double y equal square of x, then it will check the type of x here is double. All right, then it will go and search for the functions, which one is the correct one. Then it will execute this function. I'll write you, let's write the program, execute it, and see how it works. So I'll go back here. I don't need all this thing. All right, I'll define a function, integer square of integer x. Here, return x times x. And I'll end of function. All right, I'll define another function called square. Integer square of integer, but here I'll change it to double. All right. And return x and times x. Now, if I define double a equal 1.2, all right, and I write C out pair of a. Okay. And also if I define another one, which is integer b equals 5, and C out square of b. Now we'll see. It should. Let's run it and see. All right, here I have error. The error expected preliminary expression before semicolon. C out square and I'm sorry. This should not be here. Okay. All right. So if you can see, in the first case, it checked that A is a double. So it went and executed the second function, this function. All right, and returned the value, and we print it. In the second case, it checked that B is an integer, so it executed. Notice that they both have the same name. All right. So in this case, this is called overloading. That means I'll execute the function based on the argument that I passed. So in this case, I will just also print it and share it with you. So we finished the overloading also. We have another important thing in functions, which is the template. The template here, instead of using different kind of, to write just like what we've done already, we wrote more than one function. Here I can write one function, but I will change the type based on the template that we will define. So function template, compact way to make overload function. So instead of having, just like what we did already, we have two functions, one for integer, f, and double, and sometimes maybe I need float, I need more functions based on the type. So I can put all these functions in one function, but I use template. How to write it? I will write it like this: template class T. Of course, you can put any name, but the convention or it's agreed to use the letter T. Okay, that's it. Then T square of T value, return value times value. Now, when I define T here as integer, okay, here if you can see in the main function, integer x, integer y equals square. So in this case, when I used integer x, I passed it here, then all T will be of the same type. So if this is integer, then this will be integer as well. If I pass double, this will be double. Okay, if I pass float, it will be float, and so on. So in this case, it's very small modification that we do it like this. So before going to array, let's execute this. Okay, instead of having more than one function, I'll just write it like this: template. I write it like this only: template class T square of T value, value or X here, as we did it before. So in this case, it will work in the same way, but here I'm writing, I wrote only one function. So let's run it. Okay, we have error here. What's the error? Value was not, I'm sorry. Here, since I changed the type, the name of the argument to X, then everything, see? Now what happened here? I'll also take it to the slides. Okay, what happened here is we defined T. We said, all right, you have T, but what is T? Nobody knows. After that, I use T as a type. Okay, here I told the program that you have T is a type. If T is an integer, then this is T, and this should be also T. All right, integer. Okay, if it's double, then this should be double, and this should be double also. If it's a float, then this should be float, and this one also should be float. The same functionality, return x times x. Now here, I defined a as double. When I passed this argument to the function, it will not take the value only. Usually we pass values, right? It will take the value and the type. It found that the type is double and the value is 1.2. Then it changed this t to double, and this t to double. All right, and it's times 1.2 times 1.2, which is equal, I think 144. All right, I return the value to the main program. Now, in the second case, we passed b. Also, it didn't take only the value, it took the value and the type. The type is integer. All right, so I changed t to be integer and integer. Okay. Do you have any questions? Anything is not clear? Sorry? I didn't hear you clear.
Clear, doctor.
All right. Now, I'm sure you got a lot of information, especially now we have in a few slides. I'll send you an assignment before next lecture containing some questions related to the template and to the overloading, and we will discuss them after you submit your assignment. The assignment I will put marks on the assignment. All right, maybe 2 or 3 questions, 4 questions maybe, and I want you to try to enjoy your weekend working with C++. Okay. Now another important thing, which is an array or the arrays. What's the array? Okay, so can you just give me 1 second? I want to connect the charger. 1 second, please. All right. So, what's the array? I'm sure you studied all these things in C++ and programming a selected language, but since they are very important and some students may not have studied them, so I'm repeating them to you. Now, we'll talk about arrays. I need the blank slide so we can scratch a little bit. All right, so the arrays are consecutive group of memory locations, same name and type. So if I have this as the memory location, okay, I can define the array as, or let's assume that this is the memory location. I will assign or reserve some memory location for the array. So if I define INAR of 5, then INAR, if I define it like this, integer INAR of 5, let's assume equals 1, 2, 4, 6, and 7. All right. So that means it will take the first one and put it here. Then the next one will be placed here. The third one, which is 4, will be stored here, and 6 and 7. Of course, here you will find the memory address, which is not of our interest now, or it's not of our headache. You will find it like 0xFA123, etc. But in the array, I will point to this as, I'll change the name to make it easier, A, okay, even here, A, okay. I'll find it like here is A of 0. This one, A of 1. This one, A of 2, and so on. So that means I reserve this memory to save or to store the array starting from A of 0 as the first location, okay, and then I'll increase 1. Of course, here the type is important. Why the type is important? Because based on the type that I define here, I reserve the number of bytes. For example, if I use integer, then I reserve 2 bytes for every element. If it's a float, then I will reserve 4 bytes for every element. So to refer to an element, specify array name and position name. So this is the array name. This is the position of the element. The format, how to use it, array name of square brackets, okay? First element at position 0 and n element in an array, C for example, C of 0, C of 1, C of n minus 1. If you notice that here, 5, this is A of 0. This is A of 1, 2, 3, and 4. That means that the largest index is n minus 1. Okay, let's finish this and I'll explain to the next slide also. Array elements are like normal variable. Treat them like normal variable, like C of 0 equal 3, but in this case you have to write the index, perform operation, etc. Now, again, I will repeat this. If I define integer A of 5 equals 3, 2, 1, 4, 7. How many elements here we have? 1, 2, 3, 4, 5. So the number of elements is 5. Okay? Here I have A of 2, for example. This is the name of the array. Okay? And this is called the index. Okay? The maximum index is n minus 1. In this case, 5 minus 1, which is equal to 4. All right? Why is that? Because counting starts from 0. At 0. That means this is 0, 1, 2, 3, 4. Okay? This may sometimes cause some kind of confusion, but you will use to it and you will find it very direct and easy to deal with arrays. Okay? So let's see what we have and how to use the arrays. Example of using arrays. Okay? Before that, imagine that or suppose that I define this array integer A of 2 of 3. Of course, you don't need to initialize the array, but sometimes it's better using or equal 2, 4, and 5. Now, my question is, what's the index of 2? Of the element 2. I will come here and see that 2 is at 0. The answer is 0. Okay? What is the value of the element at location 3? Anybody can answer? Location means index. Anybody?
0.
Yeah. I cannot hear you louder a little bit. 0, 1, 2, 3 is outside, then I'll get error. Okay? Because I don't have index 3. I think I took, or we need to stop now because I already took all the lecture time. I'll stop recording now. Where's the? We'll continue next lecture, inshallah.